So we're moving on in Objective 2 into Part 2, where we're going to start graphing vertical shifts. So what's been happening here is we're building our repertoire to being able to graph parabolas in this form. So we looked at a x squared, where the a affects whether your parabola opens up or down, and it changes the shape. So whether it is narrower or wider. Then we moved on to the h, and the H is your horizontal translation, so left and right. And now we're going to move on to K, and we're going to look to see what K does to our graph. In order to do this, we're going to start with Desmos again. So I'm going to start with having my y equals x squared graph. Then I'm going to go on to saying, well, what if I graphed y equals x squared plus 3? Oops, that didn't work. X squared plus 3. And the difference is, the red graph compared to the black graph is it's been moved up 3. So all of our y values are 3 units higher. If I were to graph y equals x squared, but this time I wanted to do minus 3, where do you think it would go? And hopefully you're thinking down. So by putting this value of k, or this number, or this operation that's either adding or subtracting at the end of my equation, it's affecting your y values, not your x. So you're having this constant x value. So we have a point at 0, we have a point at 1, we have a point at 2, but where the y value occurs is different. So let's look at that from a table of values point of view. So if I have a table of values, if I have a table of values for y equals x squared, and I'm going to have x, y, when I plug in 0, which I know is the vertex of my standard parabola, I get a y value of 0. When I plug in negative 1 and 1, I get 1 squared, which is 1. When I plug in negative 2 and 2, I get 2 squared, which is 4. If we look at what happens if I do y equals x squared plus 3, now we said, or I said, I guess, that when you were graphing those, the x values didn't change. What happened was the y values, the whole graph was moved up or down. And that's because it's not in the bracket with the x. It's not getting squared. It's getting added 3 after you've squared. So for example, if I was to put 0 in here and I say y is equal to 0 squared plus 3, then the y value would be 3 instead of 0. It's been moved up 3 because after I squared the x value, I then added 3. If I plug in negative 1 and I add 3, so same thing with positive 1 squared plus 3, then we're going to go negative 1 squared is 1 plus 3 is 4. So when I plug in negative 1, I get 4. When I put in positive 1, I get 4. What happened? Your y values increased by 3. So if I plug in negative 2, which is the same as if I plugged in positive 2, normally I would get 4. But instead, I'm going to add 3 and I'm going to get 7. So at negative 2 and positive 2, I get 7. So then what happens if it's y equals x squared minus 3? Well, same thing. Our x values aren't going to change. We're still going to use negative 2, negative 1, 0, 1, 2. But this time y is going to equal that x squared minus 3. So you're going to square the x and subtract 3. So if we start at 0 again, because it's nice to start at your vertex, you go 0 squared minus 3 is negative 3. The y value has gone down 3. If I do negative 1 squared minus 3, so y equals negative 1 squared minus 3, that's 1 minus 3 is negative 2. It's moved down 3. So same thing here, this one would be negative 2. So if I go here, if it was 4, and I know I'm going down 3, this would be a 1. And if I check it, you get y equals 2 squared minus 3, 4 minus 3 is 1. So this k value is affecting your y value, and it's shifting your entire graph up or down. So if we go back to the notes now, I'm going to start by graphing y equals x squared. So we'll do that in blue. So y equals x squared always starts at 0, 0. Then you go over 1, up 1. From the vertex, you go over 2 and up its square root of 4. You can go over 3 and up 9. And so the same thing on the other side. We just mirror those points, or you can count them. And we've got y equals x squared here. We know that y equals x squared has a vertex at 0, 0. The axis of symmetry always goes through the x value of the vertex, and it's an equation, x equals 0. So if I go to graph y equals x squared plus 1, what's going to happen? Well, after I square the x value, so if I get 0 squared, I'm then going to add 1. If I get 1 squared is 1, then I'm going to add 1. If I get 2 squared is 4, I'm then going to add 1. If I get 3 squared is 9, I'm going to add 1. So then I can mirror these points on the other side. And what I want you to notice is that this graph, this green graph, y equals x squared plus 1, is the same shape as my y equals x squared graph, except my vertex has moved up to 0, 1, and my axis of symmetry is still x equals 0. Let's do another one. So if I now graph y is equal to x squared minus 2, my guess is that this graph is going to go down 2. So when I square the x value, 0, I'm then going to minus 2. Now this time, instead of finding the points, what I'm going to do is I know that that shape hasn't changed. There's no a value. There's nothing to make this narrower or wider. So instead of having to go through and plug in when x is 1, y is negative 1, I'm just going to do my shape. From the vertex, over 1, up 1. From the vertex, over 2, up 1, 2, 3, 4. From the vertex, over 3 and up 9. And then I'm going to mirror those points on the other side. So this red graph is the exact same shape. I wish I could do a better job going through those dots, sorry. The red graph is the exact same shape as the blue graph, exact same shape as the green graph. The only difference being that your vertex is down here at 0, negative 2. Axis of symmetry, still x is equal to 0. So now what I want you to do is pause the video, try the next two. What would y is equal to x squared plus 4 look like? What would y is equal to x squared minus 5 look like? So hopefully you're now unpausing the video, and so you're just checking. So this graph, the biggest difference is your vertex is going to be moved up 4 to 0, 4. Axis of symmetry, still x equals 0. So you're going to start here at 0, 4. Now you can either plug in that x value of 1, 1 squared is 1 plus 4 is 5, or you can go over 1, up 1. Over 2, up 1, 2, 3, 4. So it's kind of up to you. You can always be safe and use a table of values, or if you get really sick of graphing all these parabolas, you start looking for the shortcut, which is looking for that shape. And then this last one, I'm going to graph y is equal to x squared minus 5. So this is going to have a vertex at negative 5. When x is 0, y is negative 5. Axis of symmetry, still x equals 0. So you're going to start way down here, over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 3 and up 9. I could potentially go over 4 and up 16. No, I almost fit. Not quite. Okay, there we go. And there we go. So you always try to put as many points on your grid that you're given as possible. Oh, I should reach up. Oh, I'm much better with pieces of paper and a pencil. Okay, so y is equal to x squared plus k. Let's look at these features in general. Does changing the value of k affect whether the parabola opens up or down? No. Did the value of k affect the location of a vertex? Oh yeah. It's 0 and then whatever the k value is. So for example, if you have y is equal to x squared plus 2, your vertex is at 0, 2. If you have y is equal to x squared minus 3, your vertex is at 0, negative 3. Did the value of k change the axis of symmetry? Well, the axis of symmetry goes through the x value of the vertex, and since this just moved us up and down, the answer is no. All right. Before we tie it all together, I recommend trying to graph a couple of those vertical shifts in the worksheet.